thing we're working on this chapter is we're working on being able to figure out what electrons atoms should have. So when I pick a particular atom somewhere on the periodic table, how do I predict what its electron configuration is? So to do that, there are a few ways to do that. Note that the thing I have at the very beginning of this line is one way that I don't recommend learning it necessarily, but if after I tell you the other two ways to try to remember this, they just don't make sense, one option is to simply memorize the order that electrons fill in. The idea behind this is that your energy levels start from your lowest to your highest energy, that electrons like being in lower energy levels in their most stable configurations. So because, for example, 1s2 is the first orbital that gets listed, is that fixed? There we go. Yeah, so 1s2 is the first orbital here. In this list, that means it is the lowest energy, so the first two electrons in an atom that is in its ground state are going to be in the 1s orbital. After it's gotten 2 electrons, though, it can't fit anymore. So it's going to go to the next highest energy level, 2s2, which can also hold 2 electrons. And then once we're past 4, we'll go to the 2p6, and it can hold up to 6. So all the way till we get to 10, we'll keep putting them in the 2p orbital. Now, obviously that order, just trying to memorize a big list, is not the easiest way to do it, but you can do it that way if that's what you prefer. However, there are 2 other ways to do it, and if you want to do it one of the other ways, the main thing you have to remember is how many electrons each orbital holds. So an s orbital holds 2 electrons, a p orbital holds 6, a d holds 10, and an f holds 14. So the question we ask is, how else can you learn where these electrons go? So one way to help learn this is actually to look at the periodic table itself. So I don't need that. Minimize this. Okay, so if we look at the periodic table itself, we can divide it into 4 sections. Let's see, can I write? No, I can't write on this. So if you see where my cursor is, the little magnifying glass, this section over here, these first 2 columns, are called the S block. So what that means is when the valence electrons, so those are the new electrons we're adding at the outer energy level, are added to these atoms, they're added in the s orbital. And we can figure out which orbital based on what period the element is in. For example, hydrogen here is in the first period. So its newest electron goes in the 1s orbital. Whereas something like sodium here, its newest electron goes in the 3s orbital because it's in the 3rd period. Or here with something like magnesium, it goes into the 3s orbital as well, as it's still in the s block, but it will be the 2nd electron in that orbital because sodium also got one. You can use this to memorize the order by looking at the periodic table. Rather than having to memorize it completely, I can go, okay, first is 1s. Note, helium is treated as being in the s block. You have to memorize that exception because there is no p orbital for the n equals 1 shell. But after that, it goes in order, right? So lithium is next, and this is 2s. We go lithium, beryllium. Now we get to boron, though. Boron's no longer part of the s block. This block here, which starts at boron and goes down, and then goes all the way to the right, is called the p block. So this, we take the period, but now it goes into the p orbital instead. So boron would be 2p1. It still has the old electrons. This is just where the new valence electrons go. And then carbon would have a 2p2, nitrogen a 2p3, oxygen a 2p4, fluorine a 2p5, neon a 2p6. Then after neon, I go all the way back to sodium, because we keep following the numbers, and now it's in the s block again. So we go 3s1, 3s2, and we go all the way to argon to get to 3p6. We go back to potassium and calcium. These are the 4s, so our s and p blocks are enough until we get to scandium. Now that I'm in scandium, I have to worry about what's called the D block. So this is going to be everything that's in the middle here of the periodic table. I'm trying to circle with my little magnifying glass. Don't worry about this blue block thing. We'll talk about that in a second. The stuff that's down at the bottom. But these are called the transition metals, and this is the D block. So for these, we're going to put the electrons that are new into the D orbital. Although, rather than just taking the number of the period, since the d orbital is higher in energy, we have to subtract 1 from the period. So for example, scandium, titanium, vanadium are all going to put new electrons in the 3d orbital rather than the 4d. Whereas if we went down to, let's say, yttrium, zirconium, niobium, those are going to put new electrons in the 4d rather than the 5d. And so we're able to go all the way across till we get to zinc and we get to like 3d10. Note that there are some exceptions inside the transition metal block where they don't always go in the order of 4s2, 3d5, or 4s2, 3d8, or 10, or whichever they're at. Sometimes they change a little bit. You don't have to memorize those differences, though. You only have to be able to identify that it's possible. If I ask a question about something, so you still need to count the number of electrons in your system, but you don't have to memorize, for example, if chromium's an exception or not. So now that we have an S, a P, and a D block, that will get us through all our atoms, all the way till we get the lanthanum. So up to barium, we're just going to have, which is at 56, we'll have S's, P's, and D's. For lanthanum, though, now we're at this bottom area. This is the inner transition metals. These appear at the bottom. This starts the F block. So this can fit a total of 14 electrons. And for the F block, what we do is each time you add one, you add it to the N-2 block. So for example, this is supposed to be like, imagine this block cutout is up here with the row 6. This is going to be the 4F. So lanthanum, you'll have 4F1, cerium 4F2, and you add to the 4F there before adding to the 5D. Whereas if you're an actinium, thorium, these down here, uranium, these are going to be adding to the 5F. Before then, if you come back up, you would add to the 6D. So that's where I can get an order based on the 4 different blocks I have. I believe there's a diagram of this also in your textbook that talks about the S, P, D, and F block. And if you don't remember where some of those are, or it's not clear from my talking, you can go and look at those to see where it is. The goal of that is to help you memorize that order, because if we go back to my big list here, this order up top here follows the... Don't go. There we go. This order up top follows what you would get if you were to just take each electron as you go, and you fill them up as you go. Now, there's one other way which I showed in class, which I'll also demonstrate here. If you're happy with looking at the periodic table, that's perfectly fine. Just make sure you remember you still need to pay attention to how many electrons you have for things. That's just to help you learn the order they get filled in. Because things like ions will be adding or subtracting electrons. So you'll have to take your neutral atoms and then take some or add some. And you have to remember that order that they got filled to figure out where they're coming or going from. So the other thing you can do is you can make this shape here. What I do is I write the S, P, and D, and F orbitals that exist. Remember that, like, for example, there is no 1p, there is no 2d. And I'm going to write these in a line. And we're going to go down all the orbitals that exist. And we'll do this till we get to the 7s, because we can go down, for naturally occurring elements, down to our 7s. 5d, 5f. Note, some of these you're not going to use, but that's okay. And the idea behind this is something like if you're having trouble remembering, you could write it like the start of a test. And what we do to fill the order is we draw diagonal and left lines. So going from top right to bottom left. So for example, 1s fills first. I'm going to draw this line. And this line means I fill the 1s electrons first. Then after that, I draw my next diagonal line, which will go through my 2s. So 2s is next. I then draw my third diagonal line, which will go through 2p and 3s. So 2p is after 2s, and then 3s is after 2p. So we have another line, we go through 3p and 4s. Then after 4s, we go 3d, 4p, 5s, and these are just the order you put the electrons in. Then after 5s, we go 4d, 5p, 6s. Then after 6s, we go 4f, 5d, 6p, 7s. And then after that, you're going to go 5f, 6d, 7p, and wow, we're done with everything. And if you look at the order I said them as I drew lines, it matches the order you get up here if you just memorize the whole list. Note that all 3 ways will work to help you figure out the order to fill in the electrons. Use what works best for you. I don't care which way you choose to do it. There's not going to be some question of draw out the full list, or draw this shape with arrows, or show me with the periodic table. Whatever way works best for you is fine.